Yes guys, today we've got a geometry problem from the Maclaurin papers. And it reads the following. We've got a square ABCD with side length 1. X lies on AB, Y lies on AD, that's given in the diagram. AX equals X, nice and easy to remember, AY equals Y, and X is less than Y. The triangle AXY is removed to leave a pentagon, BCDYX. So that's this pentagon here. And its perimeter, so the pentagon's perimeter, is 29 over 30 of the perimeter of the square. Now the area of this pentagon is also 29 over 30 of the area of the square. Now we need to find the length of AX. So all this is saying is to find what X is. So let's start with the area. Reason being is area is always easier than perimeter in my opinion. So area of BCDYX is 29 over 30 of the area of ABCD. Oops. So we've got the area of the pentagon, which is just 1 squared minus 1 squared of the area of the square minus this little triangle here. So this total square minus the triangle. So 1 squared minus xy over 2. And that equals 29 over 30 of the area of the square, which we just said was 1. So if you put 1 there, that seems the same, fine. So let's just neaten this up. We have xy over 2 equals 1 over 30, which means xy equals 1 over 15. Nice and easy. Alright, let's put a box around it because it seems to be quite important. Now, we've got the perimeter of BCDYX is 29 over 30 of the perimeter of the square. So let's count what the perimeter of the pentagon is. So we've got 1 minus y here and 1 minus x here. And using Pythagoras, we can find that xy is just x root x squared plus y squared. So the perimeter of the pentagon, root x squared plus y squared plus 1 plus 1 plus 1 minus x plus 1 minus y equals 29 over 30 of the perimeter of the square, which is 4. Now let's simplify this. We've got root x squared plus y squared plus 4, because of the 4 single ones, minus x minus y, so that's minus x plus y. And that equals 29 over 30 times 4, which is 58 over 15. Cool. Since we've got a square root, let's isolate that term. So when we do want to get rid of it by squaring, it'll be just nice and easy. So let's bring everything else over. We have x plus y, then 58 over 15 minus 4 is minus 2 over 15. Easy. Square both sides, x squared plus y squared. Let's treat this x plus y as a and 2 over 15 as b. So we just have a minus b squared. So let's do a squared first. Or let's just write that out there. A minus b squared equals a squared minus 2ab plus b squared. And that equals, well, a squared is just x plus y all squared, minus 2ab, so we have minus 4 over 15, that's 2 times 2 over 15, times our a, which is x plus y, and then times by b squared, sorry, plus b squared, so that's 4 over 15 squared. We'll just leave it as a square. Let's get rid of this now. Let's tidy this up. So if we expand this, we'll get an x squared and a y squared term. So x squared plus 2xy plus y squared. So if you simplify all that, we'll get 0 by cancelling the x squared and the y squared equals 2xy minus 4 over 15 x plus y plus 4 over 15 squared. Now we've got xy from before, so let's just chuck that right in. So we have 0 equals 2 times x over xy, which is 2 over 15, minus 4 over 15 x plus y, plus 4 over 15 squared. Now notice how each of our terms have a 15 on the bottom, so we can just times through by 15. So we have 0 equals, actually let's times through by 15 squared, have no fractions left. So we'll have 0 equals 30 minus 60 x plus y plus 4. Right, let's neaten this up. So then we'll have 60 x plus y equals 34. Then we'll have x plus y equals 17 over 30. That's cool. So now we have another piece of useful information. So we've pretty much juiced as much information as we can out of the question. Now let's just remind ourselves of what the question is actually asking. We just need to find x. We have x plus y and we have xy. So this reminds me of this nice trick I know, which is x plus y squared equals x minus y squared plus 4xy. Let's have a look at why this works. So if you expand the left hand side, we get x squared plus 2xy plus y squared. Do the same for the left, x squared minus 2xy plus y squared plus 4xy. Now why is this helpful? Well, let's just quickly add this up. X squared plus 2xy plus y squared, and you realize that the two sides match. Yes, back to what I was saying, why is this useful? Well, if you've just got, let's write these as our two terms. You've got x plus y, x minus y, and xy. If you've just got two of these, we can always find the third by just rearranging this formula. So in this case, we have x plus y and xy. And so with that, what we can do is rearrange for x minus y squared. X minus y squared equals x plus y squared minus 4xy. Now we can just sub in what we've got. So we've got 17 over 30 squared minus 4xy, which is 4 over 15. Now all we need to do here is just simplify. So let's go ahead and do that. So x minus y squared on this side again. 17 squared is 289. 289 over 30 squared minus 4. We want this to be 30 squared as well. Well, 30 squared is just made up of 2 squared times 15 squared. So to get from 15 to 30 squared, we times by 15 and we times by 4. So we have 4 times 4, which is 16. 16 times 15 is 240. Now all we can do is just subtract. So we've got 289 minus 240, which is 49 over 30 squared. The reason why I kept it with the denominator as a square is when we do get to square rooting, it'll be nice and easy. So let's apply the square root. X minus y equals plus or minus 7 over 30. Well, let's look at this above inequality we had. We had x is less than y. So we had x is less than y. So then, when we take away y on both sides, we get x minus y is less than 0. And this implies x minus y is, well, it's just negative. It's negative. So what we do, we take the negative answer, x minus y equals minus 7 over 30. And boom, Now you may think, well, we wanted x, not x minus y. So how does this help us? Well, we did have x plus y. So if you write this underneath, you might notice that all we have to do now is simultaneous equations. So let's add these two equations, call this 1, call this 2. Let's add 1 and 2. Put add sign there. We have 2x equals 10 over 30, which is same as a third, meaning x equals a sixth. And that's it. And well, we can always check what y is and if x is less than y by just subbing back in. So let's just choose one of our equations. Let's choose 2. Well, let's choose 1. So 1 rearranged to y equals x plus 7 over 30. Y equals a sixth plus 7 over 30. Let's add these. So 1 over 6 is the same as 5 over 30. So we have 13. Well, 5 and 7 is 12 over 30. Divide by 3 on top and bottom, we get 4 over 10, which is the same as 2 over 5. Now x should be less than y. So is a sixth less than 2/5? Yes, it is, but we've got approximately 0.1666667, and we've got 0.4, and that is indeed true. So we can get rid of all that and conclude that xy, or what was in the question, ax, is a sixth. So not bad at all. We just used some nice algebra tricks, worked with this equation that looked menacing at first, and we got a pretty clean result. Well, that's all for today's video. Goodbye.